yo, algebrainiacs! Welcome to the Johnson Kendra Video Hour.
But it's not an hour.
Oh, I tell you, one of these days, it's gonna be an hour. All right, we are starting chapter 11. And of course, we're gonna start with chapter or section 1, permutations and combinations. Those are some fun words to say. All right, it has to do with probability, so this whole chapter is very probable. All right, so first thing we're going to talk about is the fundamental counting principle. That says if event M can occur in M ways and is followed by an even even n event n that can occur in n ways, then event M followed by event n can occur in mn ways. Okay, what that really means is if you have two things going on, you're going to multiply them together. All right, let's do an example. So for a family vacation, you pack 5 shirts and 3 pairs of pants. How many different outfits can you have? This is like Garanimals. We're matching. They all match together. So 5 shirts is your M, 3 pairs of pants is your N. Multiply them together. You should be able to get 15 different outfits for that family vacation. There we go. Simple as that. That's called the counting principle. Let's try another one.
That seems easy.
It's very easy. Okay. We have a Maryland license plate. It's got 2 letters followed by 4 digits. So it's easy, to set up little blanks. Now, how many, Miss Johnson, this is a quiz for you. How many letters are there in the alphabet?
26.
Very
That's
good.
That's not my area of expertise, but
right.
I'm pretty sure.
We're math, we're not English.
26.
Okay, so 26 goes in that first blank. Now, can I have double letters like QQ?
It didn't say we couldn't.
All right, then let's assume we can. So letter number 2 can also be 26 different choices. Now we have numbers to choose from. How many numbers, single-digit numbers, are there?
I want to say 1 through 9, but then I think I'm missing something.
Yeah, what about poor little 0?
0.
So there's really 10 possible single digits. So we put, and I could have 1, 1, 1, 1, or 1, 2, 3, 1, or 4, 5, 6, 3.
1986, baby.
Yeah, I was teaching already.
I was being born.
Oh my goodness. Wow. Okay, so then the counting principle says you got all these different things, you just multiply them together. And handy dandy calculator, it's 6,760,000. That's a lot of different license plates for Maryland. Okay, so
1966.
In 1966. Yeah.
Cool.
Okay, now we have a new fancy term called factorial. Look at that little box there. It says N! Woohoo!
And excited!
And excited. So what that really means is you take the first number, whatever N is, and multiply it by each number underneath it until you're done. So, for example, 5 factorial. 5! 5 is not an excited 5. It's really 5 times 4 times 3 times 2 times 1, which is 120.
I also see kids a lot of times think it's 5I because we do a lot of stuff with I.
Oh,
they're thinking
are they standing on their head?
I guess.
Jeez, get on your feet, kids. That's an exclamation point, but we call it factorial in math. Woo! Look at 12 factorial.
All right, that gets pretty tricky, so I think that we should use a calculator to do that. So when you get into class, we'll show you where the probability menu is on your handy-dandy calculator.
So we're not going to have to go 12 times 11 times
No.
10 times 10? There's a
You
shortcut
literally
button?
can type it in like this.
Nice.
And hit equals, and it tells you the answer. Let me type it in my handy-dandy calculator.
479001600. Wow, that's a big number.
Ooh. My commas are messed up.
No, that's close enough. Okay. All right, let's look at the next example. 0 factorial. That equals 1.
Why?
I don't know.
I don't know either. I don't know the real reason.
No, it's like anything to the 0 power is always 1, so it's kind of the same idea. So we just have to remember 0 factorial is 1.
If I were to forget that, would the calculator tell me that?
Yes, it will.
All right, cool.
All right.
Sweet.
Next page.
So next we have permutations, which is a funny word. Permutation is an arrangement of items, and we're talking about times when the order matters.
Now, I always forget how to remember permutations and then the next thing, combinations. Which one is the one that where order matters?
Okay, I have a silly trick.
All right, the sillier the better.
Here's a P.
That's for permutation.
That's a terrible P. And here's a C.
Yes.
Okay, so when you do a O for order, the O is closed, and so is the P.
Oh, nice.
Porter.
Porter. Yeah, I can remember that. Porter.
It's dumb. Whatever.
Hey, the more silly, the better. It's easier to remember.
So here's an example of a situation where we would need a permutation. And how many ways can 10 runners finish in a race? Maybe they win money, maybe they win a medal. It definitely matters who comes first, second, and third.
And I like to be first.
Well, everybody does.
Yeah.
Second is the first loser.
That's right.
All right. Another example would be how many orders can 5 dogs line up to be groomed? So if you are bringing your dog to the groomer and you got to sit and wait, definitely the order matters.
Yeah, I want to be first there too because my dog's got a lot of fur.
That's right.
Takes a long time to dry.
All right, another little box there. That little box says that NPR is how we're going to work with a permutation, and that's also going to be in the probability menu on your calculator. N in the NPR represents the total number of items that we are working with, like my 5 dogs, and R represents the number of items that we're actually arranging. In the dog example, it would be all 5. It would be 5P5. I'm getting ahead of myself. Let's do an example. There you go.
Get it. All right.
All right. It says, in how many ways can 10 runners finish the race in first through third place? So 10 runners going to cross the finish line. There's 10 total, so that's our N. And then the runners, we're going to award first, second, and third. So that means 3 places. That's our R. I have a question.
Yes.
Could the R ever be bigger than the N?
I don't think so.
I don't think so either. And I think, well, anyway, let's keep going, and I'll say that in a second. So 10, using the calculator, and you have to put the 10 in first, and then get in the probability menu, find the NPR, and then type a 3. And then your calculator is awesome because then you just hit equals. And it is 720 ways.
Wow, that's a lot.
Okay, so what I was talking about with the R being bigger than the N, if you type this in the calculator, it doesn't tell you error, it tells you 0. So be careful. That just, of course, there's 0 ways from 3 things to arrange 10 of them. It's impossible. So be careful. The bigger number is always going to be your N. There are times when they are the same. So next, combinations. Combinations are similar, but this is when the time that the order does not matter. So examples would be 30 students put into groups of 3. It doesn't matter if I pick Mrs. Hevlin and then Mrs. Henke and then Mrs. Kendrow as my teammates.
I might be a little sad because you picked me last.
I know, but aren't we still on
group.
the same team?
Yes.
And even if I pick you first and Mrs. Henke and Mrs. Hevlin, we're still on the same team.
Right.
Or whatever.
Yes.
Okay, 10 runners in a race, but maybe the first 4 finishers get the same prize. So you win $100 no matter where you're at.
I don't care if I'm first or fourth.
Right, you're getting the same thing.
Right.
So we have a handy dandy button for that. That is NCR. Again, find in the probability menu. And N represents the total of number of items we are choosing from. R represents how many we are actually arranging. Or sometimes grouping is maybe a better word to use here. So 30 of Ms. Johnson's students are put into a group homework quiz. Don't you wish they were all group homework quizzes?
Yeah.
How many possible arrangements are there for group 1? So we're assuming there are 3 kids in a group. So how many kids to choose from? 30. That's our N. And then we're talking about one group only, so we're going to pick 3 kids. All right, and it does not matter the order that I choose the students, they would still be in my group. So it is 30C3. We type that in the handy dandy calculator. All right.
4,060 ways.
That's
to
a
arrange
lot.
a class of 30, yeah.
That's a lot. We have a tough job, you know. All right. Next one, there are 150 books on a reading list, and you have to choose 4 of them to read. How many possible combinations? So this is maybe over the whole school year you have to read 4 different books. There are 150 to choose from. The order that I choose them in does not matter, so it's a combination. I'm reading 4, 150, C4, and that's a lot. 20260275, comma, comma.
Wow. So there's a lot of different ways to choose just 4 books out of a list of 150.
All right, I have a tricky question for you.
Uh-oh.
If we were to do 150 P4, is that bigger or smaller than 150 C4?
Oh, I don't know.
So this way, we're only counting like the groups of books. And here, we're counting the order of books. So I think there are way more ways.
Makes sense to me.
So smaller numbers for combinations. All right.
All right, now we have to decide. This is sometimes the hardest part of these problems is
Yes,
deciding, does
definitely.
order matter or does it not matter? And sometimes it's the way you interpret the problem. So, you are a DJ and you want to pick 5 songs from a new CD with 12 total songs. How many unique playlists or how many unique orders are possible?
Do you think that the order matters?
Well, the order of those 5 doesn't matter unless,
Well, what if this is my wedding or something?
and you want like slow songs
Well, you
first.
gotta do like daddy-daughter dance and all that stuff, and then the
Yeah.
chicken dance can be later.
Well, in that case, it would. So you might need a little more information to decide what kind of playlist. If it's just a party song playlist,
Right, on
then
shuffle or something like
it
that.
doesn't really matter. So it's up to your interpretation. This could be either.
When I see these words unique, lists, and I even put orders in there, those things are telling me I think that the order matters.
Okay.
So therefore, does that make it a P or a C?
Well, Porter matters, so it's a P.
So P,
12.
and it would be 12 P5.
Right.
Sweet. All right.
Okay. Last one. Okay, a pizza menu lets you pick 4 toppings at no extra charge from a list of 9.
Toppings?
Toppings? How many different 4-topping pizzas are possible? Well, I don't care if my pepperoni goes on before my peppers.
Ew.
So
Who eats peppers?
I really don't like peppers. I thought you did, so I was going to include them.
No.
I can pick them off as long as they're big chunks.
Okay.
All right, so really the porter doesn't matter.
I don't think so because you're grouping. That's how I think about it.
Right.
You're picking
They're all going to be on there regardless. So,
So,
C, and then we have 9 toppings and 4 to choose from.
all right.
Muy excelente. Okay, ta-ta for now.